This is a voiceover since when I originally recorded this video, my microphone was accidentally muted. In this video, I'm going to show how to use StatCrunch to both show a scatter diagram and to get the correlation coefficient value, the value of R. First here, we're looking at what to use as the explanatory and response variables. We're told that a pediatrician wishes to predict head circumference based on height. So height is the explanatory variable and head circumference is the response variable. Now to come up with a scatter plot, aka scatter diagram, doing this via StatCrunch. I have another video where I showed how to find this using the TI-84. So it has the data preloaded. That's an advantage. However, that advantage can't be used when working on a paper and in class. So I go to Graph and Scatterplot, tell it what to use for the response variable. And there is our scatter plot, aka scatter diagram. So looking not only at the numbers, but which things are closer to each other, either horizontally or vertically, and what things are more spread out. I'm also looking at a general trend. Except for that point furthest to the left, this looks kind of linear. So when we look at the multiple choice, I'm paying attention to that trend that I saw about which things were closer, which things were further apart, both thinking about a horizontal and a vertical direction. And we could also look at the table of data and look at specific numbers. You may want to take note that the Y value of 17.1 repeats. So apparently I did not realize the advice I just gave. I just tried choice C. It did not like that choice. Choice D, it did. Now I'm choosing this to come up with the value of the correlation coefficient R. That very first choice is the one we want. Once rounding to 3 places. You want to pick R, not R squared. See what happened with the graph. It was 2 different values of X producing the same Y value, giving a horizontal connection. We have something that is approximately linear, that was increasing. That would mean a positive slope, and R is also positive. Then I've opened up the table of critical values. We had a sample size of 8, and so I needed the critical value that went along with 8. Which is 0.707. 0.890 is greater than that. Had the R value been negative, that would have, 1, implied a decreasing linear association, if in fact it is linear, and we would have needed to take the absolute value of that before we can compare it to the absolute value. Now, given that 1 inch is equal to 2.54 inches, we take what was in inches, and both for the height and the head circumference, and convert it to centimeters. Something similar can be done on the TI-84 or even Excel. If you look up in your textbook how the correlation coefficient is calculated, it's related both to the standardization when you come up with z-scores, as well as being related to the formula for standard deviation. So this really is talking about a measurement of spread. Then we can see that R is a unitless number. So it should not matter whether height is measured in inches or centimeters, and the same thing goes for head circumference. Whether that's measured in inches or centimeters, we should come up with the same value for R. At the time that I recorded this video, StatCrunch was pretty new to me, so I was trying to learn how to set up a formula here. And once we get to the part where I successfully did so, then I will show the results. Okay, there we have 2.54 centimeters per inch times height in inches. It has taken everything in the height column and converted it from inches to centimeters. So now I'm going to do a similar thing for converting head circumference. To convert that from inches to centimeters, I would multiply inches by 2.54 centimeters per inch. So compute expression. In my new column, I want that to be coming from 2.54 times the head circumference, so that we're getting from column 2, we're coming up with column 4, the head circumference in centimeters, by multiplying column 2 by 2.54 centimeters per inch. And it's automatically filled all of those in. This time, instead of comparing column 2 against column 1, it'll be column 4 against column 3. Column 3 is the explanatory, column 4 is the response. Sure would be nice if some copy and paste was possible, but apparently not. So after entering in all the new data where height and head circumference, which were both originally measured in inches, now both of those have been converted to centimeters, which, by the way, we could have even just converted one of them to centimeters. My claim is that the R value will still be 0.890, leaving that unchanged. Stat and regression, simple linear, tell it the new columns to look at, recalling the order of the height and head circumference as explanatory in response. Looking at R, not R squared, there's the 0.890 again. It's left it unchanged. R is a unitless measurement. It has no effect when we convert measurement units.